Hello everyone and welcome to MV Tutors. I'm Tolo and I'll be doing the memo for Maths Paper 2 that was recently written now. Without wasting any time, let's just go straight to question 1. Please don't forget to like our videos and also subscribe to our channel. Don't mind my voice today, it is under the weather. Alright, so the number of pages in 10 A4 books and their corresponding weights in grams are given in the table below. The data is also represented in the scatter plot. Okay, so the number of pages, which is on the x-axis, and the weight, which is on the y-axis, is given. Now, 1.1 says, determine the equation of the least squares regression line. Okay, so that equation, I hope you remember, is y is equal to a plus bx. And once you put this information into the calculator, it can give you the value of a and the value of b. All right, so let us get to the calculator, go to the mode, which will be stats, and we are going to put in the a plus bx data. All right, let me start again. Okay, so stats. What did I do? No. Okay, so this is the part where, the calculator works a bit on you, and you just gotta get back in it and start. Okay, I don't know why it has pre-populated this data, but I will just delete it. Okay, so for x, we have 85, and then 150, 100, 120, 90, 140, 135, 105, 115, 160. Okay, we're going to go over to the y and then put in the information there that's valid. 165, 325, 200, 250, 180, 285, 250, 170, 230, and 340. Okay, so that is our information there, and you can just ignore the frequency column. So now we go shift and stat. Where is it? Oh, there it is at 1. Okay, so what do we want? We want the information. Okay. All right, shift stat, regression calculate. Sure. Okay, here we go. Yes. I was like, oh, this calculator is doing me otherwise. Okay, so for the value of a, we have negative 43,72. I'm going to round it off to 2 decimal digits or 2 decimal places. And then in the place of b, because we can see that b is the gradient and we have a positive gradient. So 2,36 x. Okay, I think for you guys, using a Casio calculator is much easier than what I have over here. All right, 1.2 says, draw the least squares regression line on the scatter plot. How many marks is this? 2 marks. So basically, this line that we're going to sketch is the line of best fit, if I could say. Okay, so I'm going to try over here to draw a nice straight line. Let's go with blue. Okay, so that line is gonna look, oh no, let me start again. It's gonna look something like this. Okay, because you want to fit in a nice line over there. Okay, so I'm just gonna say drawn. All right, I'm gonna have to hide it for a little bit. Please just bear with me so that I can see the other questions. And then I'll unhide it. Okay, so 1.3 says predict the weight of an A4 book that has 110 pages. So we're going to go to our formula. Y is equal to negative 43,72 plus 2,36 times x. X, remember, it is the number of pages. Okay, so we're going to then substitute 110 in there, and then we're going to get our answer in grams. So where is our calculator? I'm just going to go to the normal mode. I don't really like this mode. So we have negative 43,72 plus 2,36 times 110, and we get an answer of 215 and 88 grams. Okay, remember they asked for the weight, so you must give the unit in grams. And then 1.4, calculate the percentage weight increase between a book with 110 pages and a book with 130 pages. So a book with 110 pages has a weight of 215,88 grams. Now a book with 130 pages, how much will that weigh? So in your formula, I hope you didn't cancel it out there. I would put there 130, and then you get a value of 263,08 grams. So how do we get the percentage increase? Well, basically, we will then take the weight, okay, because there's an increase that happened here from 215 to 263. How much was that? Okay, so basically you're gonna take 263 minus 215,88. Okay, there was a 47,2 grams increase. Okay, and now we need to work out the percentage increase. So we're gonna have to take from the original. All right, so if I were to write the formula, let me just say percentage increase, percentage weight increase. Let me put it like that rather, percentage weight increase. So that's basically, we're going to take 263,08 minus 215,88 all over where we started, okay, 215,88, okay, which is now 47,2 all over 215,88. And remember, you're going to have to multiply this by 100, because if you don't, you're just going to get a decimal. So it is our answer there divided by 215,88, and we multiply that by 100, and so we're going to get 21,86%. And that's it for question 1. All right, question 2. Still busy with stats. So it says 50 athletes need to access suitable training facilities. The table below shows the distances in kilometers that they need to travel to obtain access to suitable training facilities. All right, so now 2.1. Okay, so we can see in our table over there, we have distance in column 1, which is measured in kilometers, and then we have number of athletes in column 2. So 2.1 says complete the cumulative frequency column provided in the table in the answer book. So we do not have an answer book, so we're just going to answer it right here. She's a blue pen. So yes, initially we have 3, and then if we add 7, that's 10. If we add 20, that would be 30. If we add 12, that's 42. If we add 5, that's 47. And at the end, you must have 50. If you have anything other than 50, then you have done something wrong. Okay, so I'm just going to write these values here, because the moment I switch off, it will disappear. Okay, so now 2.2 says on the grid provided in the answer book, draw a cumulative frequency graph or an archive. Okay, so we're going to try here on our sheet. It's not going to be to scale, so please bear with me. So what are we going to have then? Okay, I think this should be better. Not quite, but yes, we'll deal with it. This is good enough. Okay, so what are we going to have on the y-axis? What are we going to have on the x-axis? So on the y-axis, we're going to have the number of athletes because they accumulate to 50. Okay, I don't really like this. It's just not vibing with me quite well. Okay, maybe this will be better. Yeah. Okay, so we're going to have up until 50. So I will go in intervals of 10. Oh, yeah, so let's go 10, 20, 30, 40, 50. Okay, like I said, I'm not drawing it to scale. You guys had graph paper, so that makes it very nice and easy. So that is y-axis, number of athletes. Yeah, let me see if I can write it there. So number of athletes. Okay. And then on the x-axis, distance. I mean, they already hinted there. They gave it to you. So do not put number of athletes on the x-axis. Okay, so distance in kilometers. And we have until 30. So I'm also going to use intervals of 5. So 5, 10, 15, 20, 25, 30. Okay, and when you draw an archive, please make sure that you start at 0. Okay, please, you always start there. So now between 0 and 5 we have 3. Okay, so where we have 5, I'm just gonna put there. So 3 would be somewhere around here. And then at 10 we have 7. So 7 will probably be somewhere here. For 15 we have 20. So it's rising quite rapidly. And then at 20 we have, oh snap. No. What am I doing? Okay, at 5 we have 3. Please, excuse me. 5 we have 3. And then at 10 we have 10 because it needs to be cumulative. At 15 we have 30. Okay, quite a rise there. And then at 20 we have 42. So this is 45, 42 somewhere there. And then at 25 we have 47. And then at 30 we have 50. Okay, so we can draw our archive as best as we can. Ooh, not really working out from the top. Let's try from the bottom. All right, we tried. That's it. So that's 2.2. And now going over to 2.3. Calculate the interquartile range. I hope you remember this from grade 11 or grade 10. The interquartile range, basically we're taking the third quarter, Q3, the upper quartile, subtracting by the lower quartile. Okay, and now we need to go back to our graph, which will help us with the quartiles. Okay, so in terms of quartile, the upper quartile, you need to take your 50 and you need to multiply it by 3/4. That's the upper quartile. And so that you can see yeah, my values. Okay, let's do that a bit so that we have the right thing. So somewhere around there. Okay, we tried. So I'm gonna get what the upper quartile is. Okay, so like I said, on the y-axis it'll be that 50 times 3/4, and the lower quartile will be just 1/4 times 50. Okay, so let's just work that out. So 0.75 times 50, that is 37 and a half. Okay, so 37 and a half, and a quarter times 50 is going to be 12 and a half. Okay, so let's go 37 and a half. So this is 35. 37 and a half is there. Okay, so we're gonna go over a table over there. Let's just change colors. So yeah, that's 37 and a half. If we take it down, what happened now? Okay. All right, so we're looking halfway through. That would be 17 and a half, which is somewhere there. Yeah, so maybe this could be 18, somewhere about. And then we are looking at 12 and a half. So if that's 15, 12 and a half is going to be halfway. So there we go. Okay, that is not a good. Okay, something like that. Let me just shift it. Okay, it's more somewhere around there. So if this is going to be 12 and a half, this can be 11 comma something. You know what, I'm just gonna leave it as 11. Okay, so yeah, so interquartile range, Q3, the upper quartile, I get a value of 18. This is why you would get better results, because you're drawing on a graph paper. In the lower quartile, we get 11. So 18 minus 11, that gives you 7. All right, and this is now in kilometers. Cool. Now let's go over to 2.4. So 2.4 says the families of 4 of the athletes above who stay between 15 and 20 kilometers. So this is now where we are. Who stay between 15 and 20 kilometers from a suitable training facility decide to move 10 kilometers closer to the facility. In which interval will the number of these athletes or number of athletes increase? So we are here at 15 to 20. So if we then move 10 kilometers closer, I'm going to subtract 10. So 15 minus 10 is 5, 20 minus 10 is 10. So basically, here we are. This is now the new interval. Okay, they're much closer to the facilities. All right, I think that should have been just the mark. Yeah. And then lastly, 2.5, it says, calculate the estimated mean distance that the 50 athletes need to travel after the 4 families have moved 10 kilometers closer to the facility. Clearly show all working. So here, what we're going to do in order to get the mean, okay, we need to look at our table again. Remember, 4 athletes moved now to this region over here. So here we're going to have 3, but now there's 4 extra. So we're going to have 11 over here. There we stay as we are, but now we lost 4, right? So we're going to have 16 over here. No, what am I saying? We're not adding 4. We've lost 4, so now we have 8. Okay, and then this is not affected, so we're going to use it as it is. So in terms of us calculating the estimated mean distance, we're going to have to take the middle, the average basically between 0 and 5. So those are the middle terms. Okay, you can't use 0 and then use 5. You just take the average. So between 0 and 5, you're going to have 2.5. And we're going to multiply that by 3. Okay, we need to take this. And then between 5 and 10, we have 7.5 multiplied by 11. Then we're going to have 12.5 between 12 and 10 and 15 multiplied by 20. And then we're going to have 17.5 calculated, and then multiplying it by 8. And then we're going to have 22.5. and we're going to multiply that by 5. And then we're going to have, let me see if I can make space. Yeah, then we're going to have the last number over there, which is 27.5. Okay, I tried. 27.5. And we're going to multiply that by 3. And all of that we are going to divide by the total number of athletes, which is 50. Okay, so now let us work that out. It's going to be a long sum. So 2.5 times 3 plus 7.5 times 11 plus 12.5 times 20 plus 17.5 times 8 plus 22.5 times 5 plus 27.5 times 3, and we are dividing all of that by 50. So as the answer at the end, we have 13.5. Okay, and that is kilometers because that is the estimated mean distance. All right, I hope that is clear, and that is it for question number 2. All right, moving right along, question number 3. In the diagram, A, B, and C are vertices of triangle ABC. AB is produced to S. D and F are the x and y intercepts of AC, respectively. F is the midpoint of AC. So just note that. Since it's the midpoint, it means that these lengths are the same. All right, and the angle of inclination of AC is alpha. The equation of AB is y is equal to kx plus 3. So the gradient is k at the moment, and it's a positive gradient. And the equation of AC has been given to us as y is equal to 2x minus 2. So at least we know there where f is, and that is actually minus 2. Okay, cool. Now for 3.1, it says show that k is 1/3. So what we can do, we're basically getting the gradient of line AB or line AS. Okay, I'm just going to say AS. Okay, and what do we know? We have A, which is 3 and 4. And what we also do have, we know what the y-intercept is. It's 3 because the equation tells us so. So we have 2 points, we can get the gradient. And what we're going to do, so we're going to take the y-coordinate of A, which is 4, minus the y-coordinate there of the x-intercept, which is 3. The x-coordinate is 3, and then there it's 0. So we have 1/3. Okay, that's it. Simple, 1 mark. And then 3.2, calculate the coordinates of B, the x-intercept of the line AS. Okay, so our equation then becomes y is equal to 1/3 x plus 3. So if I want to get the x-intercept, y has to be 0. Okay, can write it there, x-intercept, y is 0. So there we have it, 1/3 x plus 3. I'm going to take 1/3 this side, x, and I'm going to multiply it by -3 both sides. So I'm going to be left with x on the left hand side and -9 on the right hand side. Therefore B, which is the x-intercept, will be -9 and 0. Okay, so there we have it. How many marks was that? 2 marks. And we move right along. 3.3, calculate the coordinates of C. So C, remember they said F is the midpoint. We do have the coordinates of F. We have the coordinates of A. So we can definitely get the coordinates of C. So the midpoint of AC, this is now capital M. Let me just do it like this rather. So the midpoint of AC, all right, it will be the x-coordinate of A plus the x-coordinate of C divided by 2. We have the y-coordinate of A plus the y-coordinate of C, and we're also dividing that by 2. And we know that halfway, that's where F is, we have 0 and negative 2. Okay, x-coordinate of A is 3. We're looking for C. Y-coordinate of A is 4. We're going to calculate that for C. And then we can then say 3 plus the x-coordinate of C over 2 is equal to 0. And 4 plus the y-coordinate of C over 2 is equal to negative 2. So basically, x-coordinate of C will be negative 3. If we take 2 to the other side, 2 times 0 is 0. Then subtract 3, we have negative 3. And then here, we have 4 plus yc is equal to negative 4. So negative 4 minus 4, that's minus 8. So we can then say C is negative 3, negative 8. Okay. And now moving along, 3.4, determine the equation of the line parallel to BC and passing through S. Write your answer in the form y is equal to mx plus c. So if you want an equation of a line, we need the gradient first and foremost, and we also need a point. Okay, so do we have S? Yes, they just gave us S. All right, let's just write it down. So we have a point which is S, and S is minus 15 and minus 2. Now, do we have a gradient? I believe we'll have to work it out. Okay, so this line will be something like that. Okay, parallel to BC. So if we can have the gradient of BC, we know that lines that are parallel have the same gradient. Okay, so what is the gradient of BC? So the y-coordinate, let me just throw it in here. So for B, we have minus 9 and 0, and then we just calculated C now. Minus 3, minus 8. So the y-coordinate of C is minus 8. The y-coordinate of B is 0. The x-coordinate of C is minus 3. And that of B is minus 9. So now we have minus 8 over minus 3 plus 9, that is 6. Okay, so if we simplify that, we have minus 4 over 3. That is our gradient. Now we have a gradient, we have a point. We can definitely substitute it in this equation. In the place of y, we can put minus 2. In the place of m, we have minus 4 over 3. In the place of x, we have minus 15 plus c. Okay, let me attend to the little one, and then we'll get c. Okay, so in order for us to get c, we have minus 2, and then minus 4 over 3 multiplied by negative 15. It's going to be positive, but if we take it to the other side, it's going to be negative. 15 divided by 3 is 5. 5 times 4 is 20. Okay, so c is basically negative 22. Now, therefore, we can write our equation. Y is equal to negative 4 over 3, x minus 22. And that makes sense. If you continue drawing this line downwards and you take this one over there, we might say that this is negative 22. Okay. Anyway, let me just remove that. Alrighty, so we have our formula or our equation there. Now 3.5. So it says calculate the size of A in BAC. So basically, what is this over there? All right, so what I'm going to do, what I'm going to start with, if I can get alpha, let's just use a different pen color. So if I can get alpha, then I can get this angle inside, all right? And if I can also get this value over here, I will call it, okay, if I can get this value, I'll call it beta. Then I can work out using the sum of angles in a triangle. Okay, So yes, let's get alpha first. So alpha will be 10. Okay, so 10 alpha will be equal to the gradient of this line, and we know that the gradient is 2. Okay, so then I can get what alpha is. And make sure when you're calculating your calculator is set to degrees. Okay, you don't want to work with radians. So we have 10, 2 over there. So arctan 2 gives us an angle of 63,43 degrees. All right, and it has to make sense. I mean, if you look at alpha, yes, it does look like it could be 63,43. And if we're looking for that cross there, it's basically going to be 180 minus 63,43. So let's see, 180 minus the answer, I get 116,57 degrees. Okay, and now I'm going to look for beta. So I will say 10 beta is equal to the gradient, and remember the gradient k, which is a third. So we have beta is arctan a third, and we can work that out. So shift 10 a third. Okay, and then we get 18. So the angle there is 18,443. Okay, cool. So we have beta, we have x over there. Now how do we get a? I'm simply going to say a, or let me just say BAC as they have given it to us. So BAC is equal to 180 minus 18,43 minus 116,57. You could have used external angle in a triangle is equal to the sum of the internal opposite angles. But anyway, here we are. So we have 180 minus that answer minus 116,57. So we have 44,995. I hope that you see that that is simply 45 degrees. If we round it off, even if you round up to 2 decimal places, it does still become 45 degrees. So that's our answer, which is great. That was for 5. Ooh, what a nice 5 marks. Okay, now 3.6. It says, it is further given that the length of AC is 6 root 5 units. Calculate the value of the area of triangle ABD over the area of triangle ASC. Okay. So, triangle ABD. What am I going to start with? I think I'm going to start with triangle ASC. I'm just going to rub out everything over here. Oh, maybe not that part. Just rub out here. Okay, maybe not that part. Yeah, so let's see what we can work here. So looking for triangle ASC. Let's start with that. Okay, if I want to get the area, I already have this angle here. I solved it, which is 45 degrees. Now I have the length of AC. I've been given it's 6 root 5 units. Now what I can get is the length of AS. Okay, so if I say distance AS, that's going to be equal to remember S over here is minus 15 and negative 2. Okay, so if I get the distance of AS, that would help a lot. So what is the x coordinate of A? That's 3. And that of S is minus 15. So that will just be 3 plus 15 squared. Okay, and then the y coordinate of A is 4 minus 2, which is plus 2. and all of that is under the square root. Okay, I'm just going to put it as it is so that I don't waste time calculating. So I have 18 squared plus 6 squared. And the answer is 6 root 10. Okay, so I have 6 root 10. So now I can get the area of triangle ASC, starting with the easy one. Okay, so it will be a half AC, which is 6 root 5, and 6 half AC. Maybe I should have written it down first before substituting in the values. So let me just put this a bit lower. So we can say half AC times AS sine A. Okay, so AS, we just calculated it. It's 6 root 10. And then sine 45. Again, going to put this into the calculator. So we have a half times 6 root 5 times 6 root 10 and times sine 45. Ooh, what is this now? Degree. Sine 45. Okay, then we have 90 units squared. So we're done with the area of ASC. Now let us strategize in terms of the area ABD. Let's use a different colored pen. So now this is ABD. Okay, what are we going to do with ABD? I'll still use A, 45 degrees. Should I go ahead and calculate the length of AD? I can do that. And then calculate the length of AB. Yeah, so I'm going to start first by calculating the length of AB. So AB is equal to, so what is the x-coordinate of B? It's minus 9 minus the x-coordinate of A, which is 3. And then the y-coordinate of B is 0 minus that of A, which is 4. So that's that, all under the square root. So I'm just going to put it like that. So I have minus 12 squared, which is 144, plus 4 squared, which is 16. I have 4 root 10. Okay, so that's the length of AB. Now I need the length of AD. Oh my word. I think I'm going to use the sine rule. Okay, so I want AD over, what's the opposite? Sine beta, which is equal to AB over sine X. Okay, so therefore AD will be equal to sine beta. Remember, beta was 18,43 degrees. So sine beta times AB, which we just worked out, which is 4 root 10. And then we're going to divide it by sine X. And what was X again? I think it was 116,57. Yes, the little one is agreeing. Okay, so sine 18,43 multiplied by 4 root 10 divided by sine 116,57. So we're getting an answer roughly of 4,47 units. Okay, great. Now we can get the area. Oh my goodness, how many marks is this? This is too much labor. Okay, so the area of triangle ABD is a half AB times AD times sine A. Okay, let's plug in the values. So we have a half. AB is 4 root 10. AD is 4,47. And sine 45. So I'm just going to again put that all into the calculator. So 0,5 multiplied by 4 root 10. Okay, and then multiplied by the answer that we got previously. And then multiplied by sine 45. So we get an answer of 19,99568, blah, blah, blah. If you round it up to 2 decimal digits, you're going to get 20 units squared. Now we can finally answer the question. My goodness. So the area of triangle ABD all over the area of triangle ASC. Okay, triangle ABD, we said 20. Triangle ASC, I remember it was 90. Okay, so basically that's just 2 over 9, and we can call it, yeah, we'll call it a day with this question 3. My goodness, another 5 marks which we labored for. All right, catch you at question number 4. That's it with 3. Alrighty, now we are doing question number 4, circle geometry. Okay, we're still at analytical geometry. Now it says in the diagram, the circle centered at C is drawn. So we have the x-coordinate, which is 2. The y-coordinate is unknown. Now we have A and B, which are points on the circle. And E is the midpoint of AB. All right, thank you for telling us that. Now 4.1. It says calculate the coordinates of E, the midpoint of AB. Okay, so coordinates of E, so midpoint of AB. The x-coordinate of A is 5. The x-coordinate of B is -3 over 2. The y-coordinate of A is 1. The y-coordinate of B is -3 over 2. Okay, so this is now giving us E. So 5 minus 3 is 2. And 1 minus 3 is -2 over 2. So basically E is 1 and -1. So that's just 2 marks. That is quite expected. Now 4.2 says, calculate the length of AB. All right, leave your answer in third form. So length AB, I'm going to use the distance formula. So the x-coordinate of A is 5. The x-coordinate of B, -3. So that's just going to be 5 plus 3. Y-coordinate of A is 1 minus -3. So that's just plus 3. And we're going to square that and put all of that under a square root. So 5 plus 3 is 8. And 8 squared is simply 64. 1 plus 3 is 4 squared, that is 16. Okay, 64 plus 16, that's root 80. So we can leave it like this, but I'd prefer we just check in the calculator. Yeah, I think 4 root 5 works best. Okay. It's 4 root 5 units. Yeah, they don't tell us if it's meters, centimeters, or whatever. Alright, that's just 1 mark. So they didn't really want you to waste time. They want you to just put everything into the calculator. Okay, 4.3 says, determine the equation of the perpendicular bisector of AB. Alright, in the form y is equal to mx plus c. So how are we going to do that? Well, let's just see first what's what. Okay, so what they want, perpendicular bisector, you know that the line from the center, let me just change colors here. The line from the center to a chord is perpendicular to the chord, and it also bisects the chord. Okay, so what they're looking for basically is the equation of CE. All right, so let us go ahead and do that. Well, firstly, we are going to have to determine the gradient of AB, all right? And then once you have the gradient of AB, we know that the multiple or the product of the gradients must give you -1, okay? Because they're perpendicular. So let's first get the gradient of AB. Okay, so we know the y-coordinate of B is -3, and that of A is 1. X-coordinate of B is -3 again, and that of A is -5. So we have -3 -1, that's -4, -3 -5, -8, so we basically have a half. And that makes sense, it's a positive gradient. Now then, the perpendicular gradient, then I'm just going to call it CE. If that one is a half, CE has to be -2, because if I multiply the 2, I will get -1. So now we have the gradient of CE, which is -2, and we also have a point E that we worked out, which is 1 and -1. So can we get the line, the formula of the line in terms of y is equal to mx plus c? We definitely can. So y is equal to mx plus c. I'm going to substitute -1 in the place of y, 2 in the place, or -2 in the place of m, 1 in the place of x, and then we can work out what c is, which is -1 plus 2, and that's just simply 1. Okay, so therefore our equation is y is equal to -2x plus 1. All right, so that's 4.3. And now what about 4.4? Show that P is -3. How many marks? 1 mark. So we shouldn't really labor much, should we? So we have the equation of the line, which is equal to y is equal to -2x plus 1. We're simply going to substitute the x value, which is 2. And then we're going to work out what the y value is, which is p. So -4 plus 1 is -3. And there we are. We have proved it for 1 mark. Okay, now 4.5. It says, show by calculation that the equation of the circle is that. What do we need in order for us to get the equation of a circle? Firstly, we need a center. Okay, so we are aware that center C is actually 2 and -3. Great. What else do we need? We need the radius. Okay. Why am I putting the question mark there? And we need the radius. So how are we going to get the radius? Well, C is the center, right? So if I take C to B, that's the radius, or C to A, that's the radius. So that is how I'm going to work out what the radius is. I'm either going to take AC or BC. Let's just take AC. Okay, so the distance of AC, the y-coordinate of C, or x-coordinate of C is 2, minus that of A, which is 5. Y-coordinate of C, calculated it, it's -3, minus 1. Okay, all under a square root. All right, let's just put it on the calculator, not waste time. Yeah. So we're going to get -3 squared plus -4 squared, and that is 5. Okay, that was quick. So we know that our radius is 5. Now we can go ahead and write the equation of a circle whose center is not at the origin. So we have x minus 2 squared plus y minus -3, which is +3 squared, is equal to the radius squared. Okay, 5 squared. And now we can take out the brackets. We have x squared minus 4x plus 4 plus y squared plus 6x plus 9 minus 25. If I take 5 squared to the left hand side, And then I'm going to put the x and y together. X squared plus y squared. I have that minus 4x plus 6y. Yes, we do have that. Now I am going to take 4 and plus 9. And I'm going to subtract 25. And I get negative 12. And I'm happy about that. So we have shown that the equation of the circle is exactly that. Now 4,6. Alright, so it says calculate the value of t for which the straight line y is equal to tx plus 8 will not intersect the circle. Okay, so they've given us the y-intercept. Okay, if I try to redraw this circle, let me try, so that we can see exactly what is going on. Okay, maybe not there. Maybe let me just put it a little bit up. Okay, and then let's draw the circle. All right, so what I want to then show is if let me use a different colored pen. If I have a y-intercept of 8, and I want to know what the gradient is because t is the gradient, right? So I will need to have a straight line that pretty much is a tangent to the circle because it just touches it. It will not intersect it. Okay, that's the most that it can do. It must just touch it, but not intersect it. Okay, so let's say we have something like that. I know. Let me just do it again. Okay, we'll work with that. Okay, and let's say that point is 8. Yeah, so at that point, that is where we have 8, right? So now we have y is equal to tx plus 8. So we can see that t here is positive. Okay, but there's also another way or another value for the gradient that we should consider. You can't consider anything like that because it's just going to give you a negative y-intercept, which is not what we're looking for. You also can't have something like that because it's again going to give you a negative gradient. So if that's where 8 is, let's just say, oh, this one looks like it's intersecting. Let me just move it a bit. Let's just do this. Okay, so let's just say, yeah, you have another line. Again, they meet at the y-intercept, which is 8. So here we can see that our gradient is actually negative. And this will be y is equal to tx plus 8. Okay, so there are two values of t that we need to work out. But they want to know the values of t for which the straight line will not intersect the circle. So basically, there are other options as well. You can have this line, and that line, and that line. As long as the y-intercept is 8, then we're good to go. So you basically can have more lines, okay? But let's just find out where the beginning is. And then we'll work out what the other lines are also. So how are we going to do this? I have my equation over there of the circle, which is simply x squared plus y squared minus 4x plus 6y minus 12. And I also have that y is equal to tx plus 8. Okay, now what am I going to do then? I am going to substitute the value of y into this equation. And hope for the best because my goodness. And why am I doing that? Why am I equating these two equations? Because they meet at a point somewhere, at a tangent. Okay, so I need to know what that value is. The lines cannot cross here. We can't have an intersection, like I said. Okay, So we need to find out what those barriers are. So I'm going to rewrite this equation. I have x squared plus tx plus 8 squared minus 4x plus 6 times tx plus 8 minus 12 is equal to 0. Whew, okay. This is very loaded, but let us start. Okay, so we're going to have x squared plus t squared, x squared plus 16 tx, okay, plus 64. Then we have minus 4x, x not t, and then we have plus 6tx. What is 6 times 8? 48, plus 48 minus 12. All right, so I am happy when I see this. Why? I basically now have turned my circle with that straight line to a quadratic formula, okay? And because I have a quadratic formula now, it means I can use the discriminant. But before I even go there, I need to simplify this so that I have ax squared plus bx plus c, so that I can use the discriminant. So what do I have here? I have x squared and t squared x squared. Okay, so I'm going to put that together. X squared plus t squared x squared. And then I have 16tx, 4x, 6tx. I need to put that together. So 16 plus 6, that will give me 22tx minus 4x. Okay, these two go together, those two go together. And then what am I left with? I'm left with 64 plus 48 minus 12. So that gives me 100. Positive 100, yes. And that's equal to 0. So let me write it properly again. I have 1 plus t squared. So that's basically my a. Plus, I'm thinking of 22t minus 4x. Okay, so that is my b. And then plus 100, which is my c. Okay, so then I can use my discriminant equation. My discriminant, which is b squared minus 4ac, that's equal to 0. So in the place of b, I have 22t minus 4 squared minus 4 times a, which is 1 plus t squared, times c, which is 100. Yo, Aisha, we are laboring. And it's 6 marks. All right. So let us continue to simplify. What is 22 squared? I don't know. It's 484. Okay. So I have 484t squared. And what is 4 times 22? Okay, that is 88. 4 times 22, that's 88 times 2, that's 176. So it's going to be minus 176t and then plus 16, right? That's 4 squared. Minus, let me just say 400. 4 times 100 and then 1 plus t squared. Okay, let's see here. So I have 484 t squared minus 176t plus 16 minus 400 minus t squared minus 400t squared, and that's equal to 0. Oh my word. Okay, so 484 minus 400, that's 84. All right, so I have 84t squared. And then I have minus 176t, and then I have 16 minus 400. So that is 384 minus 384 is equal to 0. Oh my goodness, now I have to use the quadratic formula. Oh, yo, the hard work never ends. So t basically is equal to minus b, so minus 176 minus b plus minus b squared minus 4ac all under a square root all over 2a. Okay, so let's work out t. Alright, so when we put all of that into the calculator, we get an answer of 24 over 7. Okay, so that's a positive gradient. So t is equal to 24 over 7, or t, if we're going to put now the negative alternative, we're going to get negative 4 over 3. Okay, let's go back to our sketch. So this t over here, so basically we have y is equal to 24 over 7 t plus 8. And then here we're going to have y is equal to negative 4 over 3 x. Did I say t? Oh my goodness. Yeah, so this should be x. Okay, x. Negative 4 over 3 x plus 8. Okay, let's go back to the question again so that we can finalize it. It says, calculate the values of t for which the straight line will not intersect the circle. Remember I said this is just it touching the circle, but the actual solutions will lie over here. Okay, so basically, and also this side. Okay, so basically t is going to be flatter. All right, if we go back, we have two options over here. 24 over 7, which is the positive one, and negative 4 over 3. So 24 over 7, that's like the steeper one. We're going to have to consider smaller values. So t is actually smaller than 24 over 7. Then we have negative 4 over 3. Okay, and we're going to have to consider values that are bigger than that because it goes and extends that side. So t has to be bigger as well, bigger than negative 4 over 3. That is basically where all these values will span, because they said they don't want that straight line to intersect the circle. Don't even touch it, hence we're not including it. Okay, we're just saying t must be in between, okay, these values. Yeah, and that is basically it for question number 4. Oh, we halfway there. Okay, we've reached question 5. There are 10 questions, by the way. So yeah, question 5.1. So it says, if sine 4t is equal to p, I'm just going to say p over 1, write each of the following in terms of p. So if it's p over 1, we know that sine is opposite over hypotenuse. So we need to have to draw our right angle triangle. All right, where we have 40 degrees over there. The opposite is p, the hypotenuse is 1. If we work out what x is, remember r squared is equal to y squared plus x squared. So r squared in this case is 1 squared. So x will be 1 squared minus p squared, and that's rooted. Okay, so that is our triangle completed. You can put the 50 there if you want to, just in case they start dealing with 50s. Oh yeah, they are dealing with 50. But yes, let us go to 5.1.1, where it says calculate sine 220 in terms of p. So sine 220 is in the third quadrant, and in the third quadrant, sine is actually negative, right? Third quadrant, we have 180 plus 40. All right, so basically this will be negative sine 40, and that's basically negative p. Now if we go to 5.1.2, we have cos squared 50. So what is cos 50? because we're going to have to just square that. Cos 50. Cos is adjacent over hypotenuse, so that's just p over 1, which is p. Okay, and we're squaring that, so basically we have p squared. Okay, then remember cos 50 is also equal to sine 40. Okay, so yeah, just a reminder there. Cofunctions, that is 5.1.3, we have cos negative 80. Remember, cos of a negative angle is actually positive, so we can just write it as cos 80. And what is cos 80? If I'm going to relate it to 40 degrees, well, 80 degrees is 2 times 40. So it's like we have cos 2 theta, cos 2x. So with this, we have 3 possible solutions. Remember, if you have cos of a double angle, you have 3 solutions. So I'm just going to go with the first, which is cos squared 40 plus, minus sine squared 40. And I know what cos 40 is. Remember, cos is adjacent over hypotenuse, so square root 1 minus p squared. Okay, and that will be over 1, and that is squared. And then I know that sine 40 is p, so that's just going to be p squared. And if I write it out nicely, the square root and the power 2, they actually cancel each other out, so I have 1 minus p squared, so basically I have 1 minus 2 p squared. Alrighty, now 5.2. Okay, so given we have 10x times 1 minus cos squared x plus cos squared x is equal to that. Now 5.2.1 says prove the identity. Okay, so I normally try to prove that the left hand side is actually equal to the right hand side. I don't want to start with the right hand side because, wow, where do I even begin? And sometimes if you see that both sides are not giving, then you can try to simplify the right hand side and then simplify the left hand side and then continue making the left hand side equal to the right hand side. But let's try first before we simplify the right hand side. So this is the left hand side. I'm going to try to prove it to become the right hand side. So I have 10x. My immediate inclination is to turn it to sine over cos, but let's just get rid of the brackets first. So I will have 10x minus 10x times cos squared x. Okay, then I have this cos squared x, and I'm trying to see if I take this common factor out, what am I left with? Will it somehow give me what I'm looking for? I see on my answer I have sine cos, and then I also have sine cos. So maybe let me just turn this cos squared x into a sine squared x. Okay, and let me turn this tan now to sine over cos. So I have sine x over cos x minus sine x over cos x times cos squared x plus cos squared x, if you change it, it's going to be 1 minus sine squared x. Then I'm going to make cos x the denominator because I see in the answer cos x is the denominator. So I'm left with sine x minus sine x times cos squared x, and then that plus 1, it will be cos x because cos x over cos x gives me 1, and then I'm going to have minus sine squared x times cos x. Okay, so now how do I go forward? I am going to try to simplify what we have over here. So now I have 4 terms, all right, and I'm trying to get a sine x plus cos x. So if I link up, let me just use a different colored pen. If I link up the sine x to the sine squared, because I don't have a squared in my answer, and then this cos x to this cos squared, let me see what that can give me. So I'm going to take out, okay, let me just put them together. I have sine x minus sine squared x cos x, and then I have cos x minus sine x times cos squared x, and that is all over cos x. So if I take out the common factor, which is sine x, I'll be left with 1 minus sine x times cos x. Okay, so I'm seeing something there, which is good. And then if I take out cos x as a common factor, I'm left with 1 minus sine x cos x. Okay, perfect. Okay, this is falling in place. So this is now over cos x. And then I can simplify it. I have the sine x plus cos x. So let me just write that down. Sine x plus cos x. And in the other bracket, I have 1 minus sine x cos x, which is exactly what we want. Okay, so ultimately the left-hand side is equal to the right-hand side, and I have proved this, the identity. Now 5, 2, 2, for which values of x in the interval minus 180 and positive 180 will the identity be undefined? So if the identity is undefined, basically it's when cos x, okay, it's basically when your denominator cos x is equal to 0. Okay, now if I were to work out the values where cos x is equal to 0, it's more than one value, but let's just start. So arc cos 0 is basically 90. Okay, 90 degrees, but this is for that interval, so it will be 90. But if we were to sketch the graph actually of cos, okay, it's at 90 and also at 180. Okay, and if you go also on the other side, it's negative 90, negative 180. So I would say, how many marks is this? 3 marks. So I would say that x, the values of x, if I were to summarize them in that interval, it would be negative 180, negative 90. Then you have 90, and then you have positive 180. Okay, those are the values where the identity will be undefined. And you can also check if you say cos 180. Oh my goodness. It's not 180, it's 270. Oh my word. Okay, let me just correct myself over here. My goodness. Let's see, it's always good to check. So this is 90, that is 180. This is 270, and that is 360. Sorry guys. So it's negative 270, and then positive 270. And 270 is not within our domain. Okay, so we can simply remove those, and then x will just be equal to negative 90 and 90. Apologies for that. I'm glad I checked the answer on the calculator, or else I would be embarrassing myself. All right, so that's 5.2.2. Now let's go to 5.2.3, or 5.3 rather. So given the expression, okay, sine 150 plus cos squared x minus 1 over 2, without using a calculator, simplify the expression given above to a single trigonometric term in terms of cos 2x. Okay, let's just write it down. So we have sine 150 plus cos squared x minus 1 divided by 2. So how can we simplify sine 150? We can then say 180 minus 30, right? And the sign is positive. And then cos squared x minus 1. Yeah, so if we, maybe let's just leave it for now, okay? Because it would be nice if it was 2 cos squared x minus 1. Okay, sorry about that. That's over 2. So now I have sine 30. Okay, I'm still going to keep the cos squared x minus 1 over 2. Sine 30 is a half. Okay, so if I have a half there plus cos squared x minus 1, a half minus 1 is actually negative a half. But rather, let me do this. Because I want 2 cos squared x there somewhere, what I'm going to do, I'm going to take a half out, okay, as a common factor. What will I be left with? I'll be left with 1, okay, plus, now a half times 2 will give me 1. So I need to have 2 in front of the cos squared x. All right, and then what happens to that negative 1? It has to be a negative 2, because negative 2 times half will give me negative 1. And then I'm going to divide that by 2. So then I have 2 cos squared x. 1 minus 2 is minus 1. So things are coming together. Now I have 2 cos squared x minus 1. I hope that you can see, or I hope that you know, that if you have 2 cos squared minus 1, that's actually cos 2a, or in this case cos 2x. And then I have a half over 2. And if I simplify that again, a half divided by 2, that's just a quarter. So quarter cos 2x. Okay. Now let us go to 5. We're done with 5.3.1. Now 5.3.2. All right, so now it says, hence, determine the general solution of that value equal to 1 over 25. So what I'm going to do, I'm just going to take a quarter. If ever they say hence, you know you're continuing from there. So a quarter to x, I'm going to make that equal to 1 over 25. And if we're getting the general solution, I'm basically solving for x here. So cos 2x, I'm going to multiply that 4 over 25. And then I have 2x. So now I'm trying to get my reference angle. So what is the reference angle again? Shift cos and then 4 over 25. My reference angle would be 80,79. So 2x. At this point in time, please do not divide by 2 because you're going to forget other things. So 80,79 degrees. Now I can go and get the general solution. Okay, so I need to see where is cos positive. Cos is positive on the first quadrant and also on the fourth quadrant. So in the first quadrant, I'm just going to say 2x is equal to 80,79 degrees plus k times 360, because that's the period of a cos function. So k is an element of integers. Okay, now I can divide by 2. So if I say that value divided by 2, I have that x is actually equal to 40, comma 40 plus k times 180 degrees. Okay, so that's my solution over there. And then quadrant 4. So when you're in quadrant 4, you can either choose to say 360 minus the angle. Okay, plus k times 360, where k is an element of integers, or you can simply say negative the angle. So you could say 2x is equal to negative 80.79. But I've chosen 360 minus, so let's just continue with that. So now if I say 360 minus 80.79, I get 279.21 plus k times 360. And then I'm going to divide by 2. So I get 139.61 plus k times 180. Okay, so if you had divided by 2 here, you would have forgotten to divide by 2 over there. That's why I say keep the number in front of x where it is until you start getting the general solution. So yeah, there we go. That is the general solution of that expression. And that's it for question 5. Question 6. In the diagram, the graphs of f of x and g of x are drawn for the interval where x is an element of negative 180 to positive 180. The graphs intersect at N, P, and Q. P is also a turning point for both graphs. Okay. Now, I see a lot of 1 marks, so I guess question 6 is going to go by quite quickly. Write down the period of f. Okay, what actually affects the period? It is the number in front of x. If x has only 1 in front of it, then the period will always be 360 for sine and cos. For tan, it will be 180. So in this case, we're dealing with cos. Therefore, the period is 360 degrees because we have 1 in front of x. Now, 6.2. Write down the amplitude of g. So where do we look in terms of amplitude? We look at the number in front of the trigonometric expression. So we have 1 times sine 2x. So we have 1. All right, and that basically tells you that the amplitude is therefore 1. 6.3, write down the value of a. Okay, so a is basically the horizontal shift that cos undertook. All right, so cos normally is like this. But we can see now cos moved from 0 all the way to 45 degrees. Okay, so that's something that you should actually see. So basically it moved to the right. Okay, so it moved to the right with 45 degrees. Okay, so A is basically, how do we write it? Because if it's a shift to the right, we're going to put there minus. Okay, so basically we know that A is 45 degrees, right? But because it's shifted to the right, it has to be cos x minus 45 degrees. If it's shifted to the left, it would be plus 45 degrees. So now we have cos x plus A. So A has to then be negative 45 because it's shifting to the right. I hope you understand that. And then now 6.4, 2 marks. So it says write or calculate the value of k, the y coordinate of n and q without the use of a calculator. So they've already given us the x value, which is 75 if you're looking at n, right? Or negative 75 rather if you're looking at n, 165 if you're looking at q. So you can decide what you're going to use there. But basically, I will go to the graph of g of x, which is sine 2x. That's basically y is equal to sine 2x. And I'm going to substitute negative 75. Okay, so y is equal to sine 2 times negative 75 degrees. And 75 times 2 is 150, but negative 150. And then we're calculating k here. So sine of a negative angle is just negative sine of the angle. Okay, And we know that 150 is in the second quadrant. Okay, so we have negative sine 30, which is just negative a half. Okay, and that makes sense because k is on the negative side of the y-axis. So that's 2 marks. And then 6.5 says, calculate the value of x. So what happened? There has been a horizontal shift to the left 60 degrees for g, and also to the left 60 degrees for f. So both f and g have moved 60 degrees. Now, where are the two graphs actually equal? I hope that you can see that they're equal at P. And what is the x value for P? Okay, it's actually 45 degrees. Now, if they're shifting 60 degrees to the left, we will have to subtract 60. So therefore, x is equal to 45 degrees minus 60. And what's 45 minus 60? It's negative 15 degrees. So that is the value for x. And you can see it's 1 mark. Okay. Now the last question for question number 6, 6.6, it says, without using a calculator, determine the number of solutions that equation has in that interval from negative 90 to 90. And that is 4 marks. I feel like you're going to do so much. So we have square root of 2 sine 2x, which is equal to sine x plus cos x. Where are we going to start? Okay, I think I want to get rid of this root. So I'm going to decide to square both sides. I don't know if I'm complicating my life, but let's see. So here I'm going to have 2 sine 2x squared. I'm just going to take the square and put it like outside. Okay, and over here I'm going to have sine squared x plus 2 sine x cos x plus cos squared x. All right. Now what am I going to do? Because I have sine 2x. Am I going to change the sine 2x, or am I going to leave the sine 2x? Let me just leave it for now. So I'm going to have sine squared 2x. Here I have sine squared x plus cos squared x. That's equal to 1. Then I have 2 sine x cos x. That is actually equal to sine 2x. So I'm going to take everything to the left-hand side. So I have 2 sine squared 2x minus sine 2x minus 1. If this is a little bit difficult for you to digest, you can say let sine 2x equal to y. All right, so then you have, yeah, sorry about that, guys. It is what it is. We need to get this memo out. So with baby crying or not, we are going ahead. So yeah, you can say let sine 2x equal to y. So then you're going to have 2y squared minus y minus 1. I hope this is easier for you to see now. So then it's easy to factorize. So you can say 2y times y, then you're going to have 1 and 1. What will give you a negative y is if you have 2 times negative 1, which is negative 2 plus 1. Okay. So basically you can say 2y is equal to negative 1, or y is equal to 1, but we are not solving for y, so just please bring back the sine 2x. So basically you have 2 sine 2x is equal to negative 1, or sine 2x is equal to 1. Now let us solve this. So sine 2x is equal to negative a half. And if we get the reference angle, so we can ignore this negative for now and just say 2x is equal to arc sine a half. And if we get that, it's actually going to be 2x is equal to 30 degrees. Okay, so now that minus, what do we do with this minus? We are basically saying, where is sine negative? Sine is negative in quadrant 2 and also quadrant 3. Okay, let's leave that for now. And let's solve this. Sine 2x is equal to 1. So basically we have 2x is equal to, arc sine is equal to 1. And if you solve that, you'll find that sine is equal to 1 at 90 degrees. So that is your reference angle. And we're going to be dealing with quadrant 1 and quadrant 2 because that is where sine is positive. So we're going to look at all the quadrants basically. Let's start with quadrant 2. Okay, so for quadrant 2, I have 2x is equal to 180 minus 30 plus 360 times k, or k times 360. And basically k is an element of integers. So 180 minus 30 will give you 150. So 2x is equal to 150. Okay, yeah, so we have 150 plus k times 360. And if we divide by 2, we have 75 degrees plus k times 180. Okay, so that's the general solution for quadrant 2. Now let us go to quadrant. No, man, quadrant 2, that's where sine is positive. I meant to say quadrant 3 and 4. Now I'm confusing myself. It's quadrant 3 and quadrant 4. Okay, sorry about that. Just distracted here. So we have 210. Okay, now what is 210 divided by 2? Let's just check that out. So that is 105. Okay, so we have 105 plus k 180 degrees. All right, so that is the first solution then for quadrant 3, the general solution. Now let's get the general solution for quadrant 4. So we have 2x is equal to 360 minus 30, because that's our reference angle, and then plus k times 360, where k is an element of integers. So 360 minus 30 will give you 330. So 2x is 330 plus k times 360. And let us divide this 330 by 2. So we get 165. So x is equal to 165 plus 180 times k. Okay, so before I move on to quadrant 1 and quadrant 2, let's just get the values for x. So if I use the value of -1, k is equal to -1, what x values do I get? So I have 105 minus 180. I get -75 degrees. And if I say 165 minus 180, I get -15 degrees. All right, if I use the value of 0, I'm going to get a range that's outside of the -90 and 90. And if I use +1, they're going to be too big. So those are the values for now. Now let's move on to quadrant 1. The reference angle there, remember, was 90 degrees. So basically I have 2x is equal to 90 plus 360 times k, or k 360, where k is an element of integers. So basically there x is equal to 45 degrees plus 180k. And then quadrant 2, all right, so we have 2x is equal to 180 minus 90 plus 360k, where k is an element of integers, and you can see there we're still gonna get 2x is equal to 90, where x is equal to 45 degrees plus 180 degrees, okay, times k. So we know that if we use k equal to 0, then x will be equal to 45 degrees. But if I use k is -1, I'm going to say 45 degrees minus 180. That's outside of the range. So ultimately, therefore, as we're done, x is basically equal to -75, x is equal to -15, and x is equal to 45 degrees. All right, and that is it for 4 marks. So much was done, but it is what it is. Question 7, we are drawing near. So in the diagram, triangle ABC is drawn. AD is drawn such that AD is perpendicular to BC. Okay, so 7.1.1, use the diagram above to determine AD in terms of sine B. Okay, so if you have your triangle over here, so it's AD, B, and we're looking for sine B. Okay, so basically sine B will be equal to opposite over hypotenuse. And we are going to put it in terms of AD. Therefore, AD is equal to AB sine B. Okay, so there we have AD in terms of sine B. Yeah. Yes. So now we're going to go over to 7.1.2. Hence, prove that the area of triangle ABC is that. So what I'm going to do, I'm going to look at the whole triangle ABC and say the area of triangle ABC is equal to half base is BC, né? Times height, and height is AD. So I am going to just leave BC as it is, and AD, I have written it in terms of AB. So AB sine B, and that's exactly what they wanted. I'll put in the brackets. That's it. 1 mark, as expected. Okay, now we can go over to 7.2. So in the diagram, points B, C, and D lie in the same horizontal plane. So what I'm going to do then, I'm going to draw the triangle BCD. Okay, BCD. And what else do we know? So in that, I see that DC is actually K. Okay, so they say ADB and ACB is alpha. Okay, I'll sort that out. CDB is theta. So this is where theta is. And DC is K units. BD is equal to BC. Okay, I'm going to draw the other 2 triangles so that I can fill in what I know. So this is A, B, D. So basically that is alpha in ADB as well as ABC. Right? That's also alpha. Okay, it helps me to just put everything down like that. And there's also another triangle ADC, but they didn't say anything about it, so I'm not going to focus on it for now. Okay, so 7.2.1 for 2 marks says prove that AD is equal to AC. Okay, so basically I am going to use now sine alpha. Okay, so in triangle ADB, okay, sine alpha is equal to AB over AD. And then in triangle ABC, again sine alpha is equal to AB over AC. Alright, so since sine alpha is equal to sine alpha, I am then going to say, let me see how I can rewrite this. I'm going to rewrite this in terms of AD actually. So I'm going to say, therefore, AD is equal to AB divided by sine alpha. And then here I'm going to say, therefore, AC is equal to AB divided by sine alpha. Okay, so therefore I see that AD is actually equal to AC. I've proven it. So that's fine. Now we can go to 7.2.2. Prove that BD is equal to K over 2 cos theta. So here I'm thinking we're going to use the cos rule. Now since I need to make BD the subject of the formula, I'll start with that. So basically BD squared in this triangle BCD. So BD squared will be equal to BC squared plus DC squared minus 2 times BD times DC cos theta. Okay. But let me just see. Oh yes. Because BC is equal to BD, then C is also theta, because I was thinking now theta is at D. So yes, C is also equal to theta. Equal lengths, equal angles. Okay. Okay. Equal lengths, equal angles. Therefore, D is equal to C. Angle D is equal to angle C. So then we can have cos C if you like, or just cos theta. Now let us try to simplify. So with BC, I think we can leave it as BC for now. Or we can say BC is equal to BD. So let's say BD squared. Okay, because they're equal. And DC is actually equal to K. So K squared minus 2 times BD. I see I already wrote BD there. I should have said BC. Okay, so 2 times BD times K, and then we have cos theta. The BD squares will cancel, so I'm going to take negative K squared to the other side. And I have negative 2 BD times K cos theta. All right, I'm trying to write all of this in terms of BD. So the negatives will cancel out, and then the K's will also cancel out. Then I'll be left with 1K. So I have 2 BD cos theta, and then I'm going to write everything in terms of BD. So it'll be K divided by 2 cos theta, and that's exactly what they wanted us to prove. All right, so that is that. And now 7.2.3 says, determine the area of triangle BCD in terms of K and a single trigonometric ratio of theta. Okay, so if I just redraw again and just put in what I know. So I have B, C, D. So BD is K over 2 cos theta. And these lengths are the same. So I have K over 2 cos theta. and I have K here. So then I can get the area, can't I? So the area of BCD, or triangle, area of triangle BCD will be a half. Let me just put in the thetas there as well. So it will be a half. Let me see which lengths I am going to choose. BC and DC. Let's see, BC and DC is DC, and then sine. So if I take BC and DC, it'll be sine C. So BC is K over 2 cos theta. DC is K and C is theta. Now I could have left it, okay, I can't really leave it there. I have K squared, all right? And then I have 4 cos theta times sine theta. I could have left it here, but they said they wanted in a single trigonometric ratio. So basically, if I take this cos over here and just leave 4 underneath here, I can then see that I'm left with K squared over 4, and sine over cos just gives me tan. So I have tan theta. So my answer is K squared over 4 tan theta. And that is it for question 7. Question 8. Thank you for still sticking with us. And don't forget to like our videos as well as subscribe to our channel. So 8.1. In the diagram, chords AB, BC, and AC are drawn in the circle with center O. DCE is a tangent to the circle at C. Now prove the theorem which states that the angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. So basically, you need to prove the tan chord theorem. Guys, I have a video which has all the examinable proofs that you need. So please do go there and watch it. It's the last video in the maths playlist, all examinable maths proofs for paper 1 and paper 2. So go there and look at that proof. I'm not going to do it here. Let's go forward to 8.2. So in the diagram, PQRS is a cyclic quad. Okay, if you hear cyclic quad, you should immediately think external angle of a cyclic quad is equal to the interior opposite angle. You should think that opposite angles in a cyclic quad are supplementary, meaning if you add them, they equal to 180. Or also you should think of the angles subtended by the same chord are actually equal. Okay, that's what you should think about when you hear cyclic quad. And they tell us that RQ is equal to RS. All right, so we have an isosceles triangle. So basically S2 is equal to Q1. And then it says ST is a tangent to the circle at S. So there you should think about the tan chord theorem. And then SR is produced to N, all right? And then R2 is 68 degrees. Okay, so we're going to have to scribble a bit on this question paper so that we can see how we answer the questions quite nicely. All right. So now 8.2.1 says determine with reasons the size of P. So where's P? This is P over here. And I'm going to look at the external angle of a triangle. Remember, the external angle is actually R2. If we have our cyclic quad over here. So our external angle here is 68. And the external angle is equal to the interior opposite angle. So P will be equal to R2. Okay, which is basically then equal to 68 degrees. And why is that? Basically the external angle of a cyclic quad. All right, 8.2.2, Q1. Okay, so Q1, this is where it is. Q1 is actually equal to S2. Okay, let me just write it down. Q1 is equal to S2. And why is that? Equal chords, because we know the lengths of those chords are equal. So equal chords, equal angles. And then S2, what do I know about S2? I don't think I know anything about it, but what I do know is I have a tangent line over here, and I have a triangle. Okay, and I know I know that S1 is actually equal to Q1. All right, so S1 is equal to Q1. And why is that? Because of the tan chord theorem. So now, if Q1 is equal to S2 and Q1 is equal to S1, it means that S2 is equal to S1. But how can I still relate that? I'm still not answering the question. I know that let me see. So S1 oh, okay, I see. I have another triangle. Okay, bear with me here. There's the tan chord. So basically S1 plus S2 is actually equal to P. All right, and that is also because of the tan chord theorem. Okay, and we know that P is 68, and we're looking for S1. No, we're looking for Q1 actually. So now I know from Q1 being equal to S2 and Q1 being equal to S1 that actually S1 is equal to S2. Okay, so that's the deduction I'm making. S1 is equal to S2. So if S1 plus S2 are equal to 68 degrees, I've done so much for this 2 marks, then I know that actually S1 is equal to S2, which is equal to 34 degrees. All right, yeah, so basically that's the long and short of this question. Now we are determining with reasons the size. Oh, am I done? Yeah. I've just said S1 is equal to S2, which is equal to 34. I should actually say which is equal then to Q1, which is what we're looking for. Okay, so Q1 is actually equal to 34 degrees. Now we can go to the next question, 8.2.3, which is S1. S1 is actually equal to 34, and that I have proved above. I've went above and beyond in the previous question. All right, and that's basically question 8. Question 9. In the diagram, AB is a diameter of the circle with center F. All right, so if AB is a diameter, it means that the angle that it subtends is 90 degrees. So basically, D1 plus D2 plus D3 is actually equal to 90. And with D1 being 37 degrees, we can get D2 plus D3, right? So D2 plus D3 is 90 minus 37, which is 53. Okay, and then center F. Immediately when I see center, I think the angle at the center, like F4, is twice the angle at the circumference, which would be C1 and C2. What I also think about is line from the center to a chord is actually perpendicular to that chord, and it bisects the chord. So basically, I can then say DG is equal to GC. Okay. Yeah, so that in a nutshell. And then AB and CD intersect at G. Yes. Do you see that? FD and FC are drawn. By the way, FD and FC are radii, as well as FA. All right. So basically, A2 is equal to C2 because equal chords, equal angles, right? So A2 is equal to C2, and also D3 is equal to, let me see, D3 is equal to A1, and A2 is equal to C2. Actually, all of these angles are equal because it's where the radii are. Okay, equal lengths or equal chords, equal angles. Okay, so yeah. And then what else? BA, so the diameter BA bisects angle A at CAD. So we know that A1 is then equal to A2, and they know they're equal to D3 and C2 and all of that. Okay, and D1 is 37 degrees. Yes, we've already seen that. So now, 9.1, determine giving reasons any three other angles equal to D1. Okay. So D1 is 37. Let me just redraw this. If D1 is 37, so if this is D, that's C, and that's A. Remember, these two lengths are the same. So D2 and D3, we said it's 53. We actually have congruent, two congruent triangles. Okay, so D2 plus D3 is actually equal to C. Okay, C1 plus C2 if you may, but it's actually equal to angle C. Why am I saying that? A1 is actually equal to A2, and G1 is equal to G2, which is 90 degrees. Okay, which is 90 degrees. A1 is equal to A2, that was given. So that would be common. So then we can say, therefore, triangle ADG is actually congruent and similar to triangle ACG. Okay. Yeah. So, yeah, what I'm trying to get to here is that C is actually 53 degrees as well. Now, what would A be if I'm looking at ADC? A would be 180 minus 2 times 53. Okay, so what is 180 minus 2 times 53? That is 74. So basically A is 74 degrees. And we said that A comprises of A1 and A2. And we know that A1 is equal to A2. So which is equal to 74 divided by 2. And what is that going to be equal to? 37 degrees. Yay. So we have A1, we have A2, which is equal to D1. And I did say that A1 is equal to A2, which is equal to D3, and equal to C2. So there we go. 3 other angles equal to D1. All right, so now let's go to Question 9.2. Okay, 9.2. Show that DG is equal to GC. But we already spoke about it. So DG is equal to C. G. So I would say loosely, not loosely actually, I would just put it that line from center to chord, line from center to chord is actually, or line from center to chord, it actually bisects the chord. Therefore, DG is equal to GC. How do they put it? Yes. Yeah, so what else do they want from us? Okay, but anyway, let's do it this way. So now that we have shown that, we could say, if I looked at triangle F, G, D, and if I looked at triangle FG, C. So I know that D2 is equal to C1. Do I know that? No, I don't. So let me not claim things. I know that G1 is equal to G2. Okay. G1 is equal to G2, which is equal to 90 degrees. Because line from center to chord bisects the chord, and it also is perpendicular to the chord. Alright, so yeah. So that reason over there. And then what do I know as well? I know that FD is actually equal to FC, which is the radius. Okay, so those lengths are equal. And what else do I know? I know that A1 is equal to A2, which is equal to C2, and is equal to D3, which are, yeah, they're equal to 37 degrees. Oh yeah, it's another one, D3. Okay, so if I know all of those, I can work out what C1 is. C1 will actually be equal to D2, which is 50, what's that angle again? 53 degrees minus the 37 degrees. Alright, so 53 minus 37, I think I had gotten that. So that's 19 degrees. Alright, for C1 and D2. Oh, I could have said F2 is actually, if we go here, if we draw in that chord BC, F2 is twice the angle at the circumference, okay, which is A2. So F2 is twice A2, and F1 is also twice A1. Alright, and we know that A2 is equal to A1, right, which is 37. And if you multiply that by 2, that's 74. So basically, F2 is equal to F1, which is equal to 74 degrees. All right, and there I could have said, sorry, I forgot to provide the reason, angle at center. All right, so having done that, I've shown that the F's are equal to each other, that D is actually equal to C, and G is equal to G. So yeah, and also FD is equal to FC, FG is equal to FG, because it is what it is. Therefore, therefore DG has to be equal to GC. I guess that's what they wanted. All right, and yeah, that's that. And then the last question, which is 9.3. So it is further given that the radius of the circle is 20 units. Calculate the length of BG. Okay, so I think I'm going to need another color which is thicker. So the radius, okay, the radius is 20 units. So basically FB, so FB is 20 units. All right. And then they want the length of BG. FB actually consists of BG and FG. All right. So we are looking for BG. And in order to do that, we need to get what FG is, which if we look at our triangle over here, yeah. So let me just rather go here. Okay, so I have FG, C, or D, doesn't matter. Yeah. Or actually, if we're looking for BG, how many marks is this? It's 4 marks. We have 37. We know that G is 90 degrees. I don't have to go the long way that I'm thinking. Yeah, I was already thinking something else that's going to take a very long time. But instead of looking at FGC, or maybe FGD, let me just see what information I have. I know that G is 90 degrees. I know that D, which is D2, I've already solved it. It's 19 degrees. And F1, I also solved it. It's 74. Aibo. No, that can't be. If F1 is 74, then D2 cannot be 19. Okay, something. I did something incorrect there. So, yeah, no, that's 71. No way. So it means the previous question that I did, something is wrong there. And if I look at this triangle, B, G, D, I'm just drawing it the other way. I know this is 37. So B has to be 180 minus 90 minus 37, 53. So B has to be 53. Okay. Yeah, something is not adding here. So D2 has to be 16. Where did I get 19 from? I said C1 is equal to D2, which is 53. Why did I say that? Because I said D3 is 37. So 180, no, 90 minus 37 is 53. And 53 minus 37 is 16. My goodness, where did I get 19 from? Yeah, no, today I didn't Zala. Sorry, guys. This should be 16. I don't know where I get this. Okay, now things are making sense. So this has to be, because I was about to like re-record and I don't have much time. I'm limited for time. The baby needs attention. So if this is 16, then I know that F has to be 37, right? Sorry, 74. 74. Yeah, so 90 minus 16, that's 74. Yes, now things are coming together. Oh, my word. I almost had a heart attack. I have to now do things again. So yes, I could either use FGD, all right, to get the length of FG and then ultimately get the length of BG, Or I can just calculate BG straight. Yeah, so let's just go ahead. But the thing though, I can't really use BDG because I need to use the radius, which is 20 there. That's FD. So yeah, I'm forced to use FGD. So I have 20 and I'm looking for FG. So if I say sine 16 is equal to FG over FD, I know that FG is 20 sine 16. And what is 20 sine 16? 20 sine, yeah, it's been a long day. 20 sine 16 is actually 5,51 units. Alrighty, so now I can finally get BG. Therefore, BG is 20 minus 5,51 units. And what would that be? 20 minus the answer. That's 14,49. 14,49 units. Guys, I am sorry for the runaround there. Silly mistakes. Silly mistakes. We are all susceptible to make such mistakes. It's just a matter of identifying it quickly, especially when in an exam. But unlike me, you guys are not writing with a baby and a toddler, so you guys will not be susceptible to making such mistakes, right? Okay, so that's it with question 9. We are finally here, question 10. Let's finish strong. In the diagram, COD is a diameter of the circle with center O. Okay, so as soon as you hear diameter, you know that the chord, if the chord is a diameter, the angle that it subtends will be 90 degrees. Okay, so let's see. CD is a diameter. It means B1 and B2 is 90 degrees. All right. And what else? Is there any other triangle? Yes. F2 and F3 are actually 90 degrees. And if we have a center, you know, angle at the center is twice angle at the circumference. So if you can see anything, I can see chord CB, there O1, and then D1. And I'm sure there are many of them, but let's move on. EA is a tangent to the circle at F. Okay, if we have a tangent, you're going to look for a triangle. Okay, so triangle over there. There we go. So we can use the tan chord theorem. So I know that F4 is equal to C2. Is there any other triangle? No. Not that I can see. I can't see anything now. And then AO, okay, I see AO, is perpendicular to CE. And then diameter COD produced intersects the tangent to the circle at E. OB produced intersects the tangent to the circle at A. Okay. CF intersects OB at T or in T. CB, BD, OF, and FD are drawn. Okay, great. Now, 10.1. Prove with reasons that TODF is a cyclic quad. Okay, let's use a different colored pen. So basically, T, O, D, and F are a cyclic quad. So there's an imaginary circle that's there. So there are 3 ways of proving whether something is a cyclic quad or not. You can take angles from the same chord. Angles from the same chord are equal. Number 2, you can say the external angle of a cyclic quad is equal to the interior opposite angle. Or you could say that opposite angles are supplementary. 3 options. So the first option, if I look at OTDF, I can't really use it. Okay? Oh, I can. If I can show that O2, I'm going to have to erase here. So many things going on. I can actually show, okay, I can use it if I can prove using this chord that O2 is equal to D2. Where will I even begin? Or I can use external angle in a triangle. Okay, so let's see, what external angles do I have? I think I have quite plenty of them. I have O1, which is 90, and yes, I said F2 and F3 are actually equal. Yes, I'm using this one. So basically, what am I going to say? I'm going to say O1 is equal to F2 plus F3, which is equal to 90. So F2 plus F3 is called as a diameter. Okay, an angle subtended by a diameter is 90 degrees. And O1 is equal to 90 degrees because that one is given. They told us. So therefore, O1 is equal to F2 plus F3, which is 90 degrees. And why is that? External angle of a cyclic quad. Okay, so that's 10.1. For 4 marks, I think that is valid. Yeah, so you can write it out nicely. Start with O1 being 90, that's given. F2 plus F3 is 90 because the chord is the diameter, that's another mark. And then you relate O1 with F2 and F3, that's another mark, and then reason external angle of a cyclic quad. All right, and then it says prove with reasons that D3 is equal to T1. So D3 is an external angle of a cyclic quad, and it's equal to T1. So basically, I'm going to say D3 is actually equal to T3. Again, external angle of cyclic quad. Sorry about that. Okay. And then T3 is equal to T1. Okay, vertically opposite angles. Okay, so yeah. Therefore, ultimately, D3 is equal to T1. There we go. Okay, now 10.3. So prove with reasons that triangle TFO is similar to triangle DFE. Alrighty, so I am just going to remove everything from here. And let's see, where is T, F, and O? So this is T, F, O. I'm going to draw it just like that. Okay, so we have T, we have O, we have F. I'm just going to call it F2. And this is T3. And that is O2. And that is similar to triangle DFE. Okay, so D, F, E. Oh, okay. I'm going to rotate it. I'm going to rotate it and draw it sort of like the same way as I did TFO. So starting with D, D would be there. DF, there's F, DFE. Okay, so this is now D3. And that is now F4. Okay. Now, if I'm going to prove similarity, I need to show that the angles are actually equal. So, what can I start with? Yeah, recording this video has been a challenge and a half, but we soldier on Yeah. So I'm going to look at T and D because those are the first in line. Okay. So how can I show that T3 is actually equal to D3? T3 is there. D3 is there. Oh, remember we said that this is a cyclic quad. TODF, right? So D3 is actually equal to T3. Okay, external angle of a cyclic quad. I actually proved it before. So I should just say proved. Cyclic quad. Okay, then I'm going to go to F. So I'm going to show that F2 is actually equal to F4. Okay, this is F4. Where's F2? Here's F2. Okay, how am I gonna start? Ooh, okay, remember, okay, therefore, so I'm gonna say, remember that F4 is actually equal to, if we're looking at this triangle, F4 is actually equal to C2, okay, and that would be the tan chord theorem. Okay, so F4 is equal to C2, and then I know that, okay, so OC is equal to OF, because those are the radii, okay? Therefore, C2 is equal to F2, okay? C2 is equal to F2, equal chords, equal angles, equal length, equal angles. Okay, so we know that C2 is equal to F2, therefore F4 is equal to F2. Okay, and then lastly, we can then look at O and F. So basically O, no, O and E, O and E. So that's basically O2 is equal, this is O2 now, is equal to E. And yeah, I'm just going to say, well, that's the common one left if you take angles in a triangle equal to 180 degrees, or sum of angles in a triangle equal to 180 degrees. So therefore, we can conclude, that triangle TFO is indeed similar to triangle DFE. 10.4, now it says, okay, let's remove everything so that we can see clearly. So it says, if B2 is equal to E, so basically if B2 is equal to E, prove that DB is parallel to EA. All right, so I know that B2, just by looking at it here, I'm looking at this triangle. I know that B2 is equal to D1. All right, and why is that? Well, basically equal chords, the chords are equal in length, okay? Equal chords, equal angles. All right. And they've just told me that B2 is equal to E. Okay, that's given. All right. Yeah, those equal chords, let me just say OB is equal to OD. And that's the radius. Okay, now B2 is equal to E. That's what they told me. So I'm saying B2 is equal to D1. And B2 is also equal to E. Therefore, D1 is equal to E. And if both of them are equal, it means that DB or BD is actually, and let me just say BD, DB rather. So DB is actually parallel to EA. And the reason, corresponding angles. Okay, that was a nice one. And then lastly, 10.5, I'm losing my voice, I'm coughing, I'm making silly errors. We are here at the end. So it says prove that DO is equal to TO times FE over AB. Okay, remember we said that triangle TFO is actually similar to triangle DFE. We're going to use that, okay? So we know that triangle TFO is similar. Well, I think we're going to use that. We better use it. Okay, so then I'm going to say TF over DF, okay, start with these two, is actually equal to FO over FE, which is equal to TO over DE. Okay, so what do I have? I have TO there, so great. I have FE. Okay, so this is the chunk that I'll be using. All right, so I will say FO over FE is equal to TO over DE. So FO is TO times FE over DE. So I already have TO, I have FE. Great. Now, how do I make FO equal to TO or DO? Let's go and check. Where's FO? Okay, I'm going to use a different colored pen. So this is FO. And where's DO? Ah, two radiuses. So basically, FO is equal to DO. Okay, because those are radii. Okay, therefore we have DO, which is equal to TO times FE over DE. We're almost there. Now we're left with AB. So, I have this big triangle. This big triangle over here, which is OE, OEA, and I have D over here, and I have B over there. Okay. So now this angle is equal to that angle, which is equal to this angle, which is equal to that angle. And so using the proportionality theorem, I can say that OD over DE is equal to OB over BA. And I know that OD and OB are equal. Again, these are radii. Okay, so if they're equal, I can basically cancel them out. Okay, what do I mean? If I divide by OD is equal to OB. So basically I have 1 over DE. Oh, by the way, this is the proportionality theorem. Where DB is parallel to EA. Okay, so 1 over DE is equal to 1 over BA. Okay, if I cross multiply, I'll have that AB is actually equal to DE. Okay, which is great. Because I can therefore conclude that DO is equal to TO times FE over AB, which is what they wanted. Yeah. And we are done, ladies and gents. We are done. Paper 2 is done. Now I need to look at physics paper 1. But yeah, this is it. Thank you so much for tuning in. I hope you've learned something. I hope this helps you to prepare for your exams. Yeah, those who are writing in June, because this was a supplementary. So those who are writing matrics, who are writing, I hope this helps to prepare. And those who are writing in November, I hope this also helps you to prepare. And please don't forget to like our videos as well as subscribe to our channel. and write in the comment below how we can best serve you. That's it from me. Goodbye.